You are all welcome to our studies in atomic structure and bonding. This is Chambogo University Department of Environmental Science. Undergraduate studies in environmental science, technology, and management. This is semester 1 of 2022. I'm Dr. Grace Kizito Bachaita, who will be taking you in this course. In the beginning, let's look at our major issues in the course outline. We have learned before in earlier studies that matter is that which has mass and occupies space. But that is not an end in it. Matter consists of smaller units, and in those smaller units, the ones that normally come up are the molecules. These can actually exist as independent states. Like, for example, when we talk about noble gases, in noble gases we sometimes have atoms existing, atoms of those noble gases, whereas in other atoms they come into combination and they give us molecules. In all these particles that we have mentioned, the smallest particle is the atom. It is made up of subatomic particles, and we find these subatomic particles arranged in a very systematic way. So in what we call an atom, as we are going to start our studies, I want you to remember our studies of geography in a lower school or secondary or primary. In geography, we learned about the solar system, and the solar system had an arrangement in which the sun is at the center of the solar system. It does not move, it is stationary. But in the space that surrounds the sun, we have planets. There are several planets that are known, including ours, the Earth. These planets normally move. They revolve around the sun. For example, we'll use the example of the Earth. It revolves around the sun, and it also spins on its axis. It takes 24 hours to make one spin. In that one spin, at one moment, one part of the Earth is exposed to the sun, and that side there is daylight. And as the spin goes on, that half or side of the Earth may be turned away from the sun. And when it is turned away from the sun, darkness falls, and that is night. It takes 24 hours to do one spin. When we talk about the revolution we have talked about, the Earth takes 365 days to make one complete revolution around the sun. When we look at that kind of setup of the solar system, we find that it is very wonderful. It's on that we build our explanations and understanding of an atom. So matter is that which has mass and occupies space. It is made up of one or more elements. There are so many elements that are known. There are different states of matter: solids, liquids, and gases. The particles in solids and liquids and gases are arranged in such a way that it is easy to differentiate that this state is a solid, this state is a liquid, and this state is a gas. The simplest will be that the particles in gases, that is to say the molecules, they are very mobile, and the relationship between one another sometimes is very, very limited. So you find that they easily spread and diffuse into the environment. They have that kind of freedom. They do not have bondage. They do not cling onto one another. That means they don't easily stay together. So the molecules in gases are mobile and they have freedom of movement. When it comes to the particles or the molecules in liquids, these ones are bound together, and normally liquids keep the liquid molecules keep close to one another. We have some forces that keep them together. And when it comes to solids, the way they relate to one another, the particles in solids relate to one another in such a way that they don't even have the probability of moving away from one another. They just have vibrations between them, but they keep close together, and that is what makes solids have a definite shape and a definite volume. For liquids, yes, the volume can be definite, but there is no shape. They actually take up the shape of the container. For gases, we said they are very mobile, very free. The molecules are very free to move elsewhere and in all places and every direction. When it comes to the elements that we know, the noble gases are known to be very stable, and for them they have atoms which can exist as atoms. Reason is that in these atoms there is a less likeliness of these atoms to combine. They have full outermost orbitals, duplet and octet number of electrons in the outermost orbitals. Therefore, they don't easily take part in chemical reactions, and therefore they can keep on their own. Other elements occur as groups of atoms associated with one another, or molecules. An atom is the smallest indivisible component of an element whose constituents are electrons, protons, and neutrons. The atom. Protons and neutrons reside in the nucleus and account for the mass of the atom. Sometimes the total number of protons and neutrons is what is referred to as mass number. The number of protons in the nucleus is the atomic number. The elements are numbered and are arranged in a periodic table by their atomic numbers. As the atomic numbers increase from 1 onwards, we normally, in this periodic table, we normally fill rows. The rows are filled with atoms from left to right. At the same time, we have columns that result, and the columns also fill as we go downwards from top to bottom. We shall talk about them in a short time to come. On the other hand, protons carry a positive charge that is balanced by the negative charge carried by electrons. The positive charge of protons is equal in magnitude to that negative charge of the electrons. So an atom has no net charge, and therefore it is electrically neutral. The neutrons have no charge at all. When it comes to the other properties of these subatomic particles, protons have a mass of unit 1 and neutrons have a mass of unit 1. Electrons have a mass which is 1 out of 1864. So it is a very negligible mass as compared to the mass of the proton and the mass of the neutron. And therefore, all the mass of the atom is contributed by protons and neutrons, and it is concentrated in the nucleus. We have several scientists who have lived before us and have done a good job. They have actually studied these atoms, and they have come up with suggestions, with models, with postulates, which we now make use of so that we easily understand the atom and we easily appreciate what the probable structure of an atom is. The first scientist that we shall look at is J.J. Thomson. He came up with the postulates and an atomic model. We shall look at the features of the J.J. Thomson's model. The features are: all the atoms contain electrons which are negatively charged. Number 2, atoms are electrically neutral entities. Every atom thus contains enough positively charged matter to balance the negative charge of the electrons. 3, electrons are several times much lighter than the whole atom, implying that the positively charged constituents provide nearly all the mass of the atoms. Thomson proposed that atoms are uniform spheres of positively charged matter in which electrons are embedded in the spaces outside the nucleus. When it comes to the other scientists who we want to look at and whose work we want to appreciate, Rutherford. The Rutherford atomic model. The features of Rutherford atomic model are: an atom comprises a tiny nucleus in which its positive charge and nearly all its mass are concentrated, with the negatively charged electrons some distance away. This model had limitations. So limitations of Rutherford's model: 1, it could not account for the stability of the atom. 2, it predicts that electrons will radiate electromagnetic waves of all frequencies, which will result in a continuous spectrum. But what is known is the following: atomic spectra are not continuous but discrete. They normally radiate electromagnetic waves in what we call discrete portions corresponding to specific frequencies. So we do not, therefore, have a continuous electromagnetic radiation from our atoms or from our electrons in the atoms, but simply we have different series of discrete specific frequencies, which implies that actually our electrons occupy different levels within the atom. For another scientist that has to be considered is Bohr. Bohr's model of an atom had the following: that the electrons exist only in stable circular orbits of fixed energy. Number 2, an electron will emit or absorb energy only when making a transition or a change from one orbital to another possible orbital. This can occur when an electron moves from a lower energy level to a higher energy level. It has to then take in energy That's when absorption turns up or comes about, and then we have absorption spectra. In case an electron falls from a higher energy level to a lower energy level, it emits energy, and then we have emission spectra that result. These are the ones that we mentioned earlier on of electromagnetic nature. The atom is electrically neutral. The negative charge is equal to the positive charge of the atom. The other postulate of Bohr's model of an atom is that the entire positive charge of the atom is concentrated in quite a small volume of the atom, the nucleus. Bohr's model of an atom still continues. The angular momentum of an electron in an orbital is quantized. That is, it takes only specific values that are integral multiples of the Planck's constant. The other postulate of information we can pick from Bohr's model of an atom, the electrons only radiate energy when they make transitions from one orbital to another. The transition could be a result of the electron receiving energy from an external source, which we sometimes refer to as excitement. We have shapes of atomic orbitals. Although earlier scientists had postulated that our electrons exist in spheres, to some extent, yes, it's correct, but to a greater extent, no. Those who have been studying, the scientists who have lived before us and have studied these atoms further using modern machines or instruments, they have actually come up with ideas that try to explain how these electrons actually arrange themselves in the space outside the nucleus. The electrons exist in orbitals with various shapes and energies as shown. You can see on your slide, the s orbitals have been colored as light blue, the p orbitals as pink, and the d orbitals have an orange color. When you look at the s orbitals, you will realize that these look like small spheres. Therefore, the s orbitals are spherical, but the p orbitals are dumbbell shaped. The dumbbell shapes of these p orbitals tend to show that we have two lobes on either side of the internucleus axis. We have these lobes lying along a particular axis. If the lobes lie along the z-axis, the p orbital will be referred to as pz. Whereas if they lie along the x-axis, then it will be referred to as the px. And if they lie along the y-axis, then that one is the py. Therefore, amongst p orbitals, we have px, py, and pz. When it comes to d orbitals, the d orbitals have unique shapes, and these unique shapes normally give us planes in which the electrons will be most likely expected. And if electrons will be expected in a plane that pays respect to one or two axes, then we are going to be having these planes referred to as dxy, dyz, dyx, or xz, or x squared, and so on. Those are d orbitals. When it comes to electron distribution, we can take an example of carbon. Carbon is an atom that has 6 electrons, 6 protons, and 6 neutrons. That is the normal carbon. But carbon has an isotope. An isotope is an atom of the same element in which we find extra number of neutrons present. Carbon has an isotope which is referred to as carbon-14. Carbon-14 has 6 electrons, 6 protons, and 8 neutrons. But as of now and today, we are going to use the example of carbon-12. The orbitals of the carbon atom will be in this form. In your earlier studies, and actually in secondary school, you used to call the arrangement in which we have how the electrons distribute themselves in an atom. You used to refer to that as the electronic configuration, and we still say the same at this level. What we are going to state here or describe for carbon atom is the electronic configuration. It has the first electron shell, which has one s orbital and which can be filled by 2 electrons. These 2 electrons, normally the ones that can exist in an orbital, are electrons that have been paired up. How do these electrons pair up whereas they have a negative charge? Earlier studies showed that when we have an electrically charged particle that moves, if it moves in a magnetic field or if it moves in an electric field, normally we have work done. That is why when we refer to our physics, our earlier studies of physics, we had the following to say, that when a charged particle is very far away from another charged particle, there is no influence at all. They don't influence each other. They have no effect on each other. But when they move and move and move closer, there is the smallest distance that we can talk about when they are far apart but close enough to influence one another. In such a situation, we say that one charged particle has come into the field of another. The field is that region or space around a charged particle in which its influence is felt, or in which its influence is going to affect other charged particles. The effects are such that if a positively charged particle exists and another positively charged particle comes close, in that region we have just described, there will be a tendency of repulsion, push away. So one charge will push away the other when it comes close in that region we have referred to as the electric field. On the other hand, if it is an oppositely charged particle that comes close and gets into this region, there is a tendency of pulling or attraction that will be experienced by the charged particles. So they tend to attract one another. Now, if we have these charged particles and we have been discussing them as stationary objects or objects that have no other form of motion, in case we have an electric particle, electrically charged particle that is going to be moving in this form, spinning the way we talked about the earth. If we have a charged particle that is moving in a form of a spin, at the same time it comes closer. If it is making two kinds of motion, a spin and then linear motion. It is moving towards another positively charged particle, but it is also spinning. If the one that is in one place is also spinning, if they spin in the same direction, we normally have fields which are generated or regions generated around them of the same kind. Therefore, they will repel when they come close. But in case they are spinning in opposite directions, they generate fields which are opposite. When they come close to one another, they attract. That argument is the same argument that we have for electrons, which are negatively charged. They are negatively charged, but if they spin in opposite directions, they generate fields which are opposite, and therefore when they come together, they attract. That is how they can come to pairing up. Now, going back to our carbon atom, the first electron shell has one s orbital with 2 electrons. Then the second electron shell has 2s orbital which has 2 electrons. In that second electron shell, we have 3p orbitals, 2px, 2py, and 2pz orbitals. The 2 electrons that remain, they occupy these orbitals because they are of equal energy. They first occupy them singly. So there is an electron in the 2px and there is an electron in the 2py, but there is 0 electron in the 2pz. That orbital in the electron shell which has 0 electrons is normally referred to as a vacant orbital. Therefore, there are 2 2p orbitals that are singly occupied and 1 vacant 2p orbital in the second electron shell of the carbon atom. I would like to thank you very much for your attention in this first session of our studies and our lecture series and our presentations. You'll be reflecting on the knowledge that we have gotten from this discussion and also the slides that have been prepared. There is a lot of information behind. Only summaries have been presented, and therefore it is important to reflect on the details as we move along. I will be welcoming you soon to our next series. Thank you very much.